Just a year ago, development with AI basically meant using Claude models. Other flagship models like GPT, Gemini and Grok were lagging behind Anthropic. But things gradually changed. Since late 2025, OpenAI has been releasing extremely powerful GPT models that beat Claude Opus on many tasks. Personally, I moved from Claude Code to OpenAI Codex several months ago. I give it about 90% of all my tasks now, because the quality of the result is almost always higher. There are no problems with token limits, the subscriptions are very generous. Also, in February 2026, OpenAI released the extremely convenient Codex app. It combines the power of console-based development tools like Codex CLI and Claude Code with the visual convenience of a nice desktop app. So today's video is about Codex. We'll look at all of its forms: Codex App, Codex CLI and Codex Exec. I'll show the main features in this ecosystem. We'll go from the basics of working with AI agents to experimental mechanics and the internals of these tools. Also, I'll explain the nuances you should keep in mind when working with them. And as per tradition, we will do it by building fun projects. By the end of this session, we'll have a powerful AI assistant, something like Jarvis. By the way, my name is Oleg. On this channel I experiment with AI, test neural networks and tools, and show what works and what doesn't. Let's start right away. Let's open the Codex app, choose a folder for today's projects and work there. In Codex, folders are shown on the left, and all chats you start inside them are grouped by projects. I'll ask it to make me a Counter-Strike 1.6 clone with bots on the Dust map. Let's see what happens. As you can see, Codex starts running different commands directly on my computer. It checks what's inside the current folder, confirms that it's empty, and starts creating the game files. After some time, the program is written, and Codex starts testing the game in the browser. For that, it runs the game on a local server and uses Codex built-in browser control to click around and make sure everything works. This is the game we ended up with. Development took around 14 minutes. So how is Codex different from basic ChatGPT? Codex doesn't run somewhere in the cloud, it runs specifically on your computer. That means it can build programs precisely for your system and your hardware, and work with your personal document library. What's also extremely useful is that you can clearly see what your agent is doing, which files it touches and which commands it runs. So to do this kind of thing locally, you need to install Codex app on your computer. Working from the browser won't be enough. To install it, Google Codex app, open the first link, download it, install it, and log in with your ChatGPT account. The subscription is shared, you can start with any plan, even the cheapest one. But for normal development without constantly worrying about limits, I would recommend aiming for the $100 plan. And if even that somehow isn't enough, then try the $200 subscription. It costs twice as much but gives 4 times the limits. Let's upgrade our Counter-Strike a bit. It has a few problems. First, the bots are flying in the air. Second, the AK-47 in the player's hands looks very crooked and weird. And overall, everything looks kinda dull. Let's ask it to add textures. By the way, earlier, when Codex wanted to test the game, it tried to run a Python command to start a local server for the game. By default, the current access mode pauses the agent until the user approves the command. This behavior is enabled automatically for all new console commands with new parameters, and for all new tools. Because of that, you used to have to choose between two bad options, either constantly blocking your development with endless command approvals, or giving the agent unlimited permission to perform absolutely any action, which isn't exactly safe. OpenAI recently tried to solve this dilemma by adding an access mode called Auto Review. Here is how it works. Whenever a command appears that requires human approval, the call gets reviewed by a separate agent. If it approves the call, the process continues normally. If it rejects it, then the agent either looks for a safer workaround or asks a human for manual approval. In practice, Auto Mode works really well. I use it about 90% of the time now. Sometimes I'll also enable the dangerous mode for processes that I definitely don't want interrupted by sudden approvals. But for this current improvement, Auto is enough. Let's enable it and ask Codex to patch the game. Let's start it. After some time, we see sandy textures appearing in the chat. Where did they come from? Codex used the ImageGen skill. This is a built-in Codex capability for generating images. Inside it, the model is the same as in ChatGPT, GPT Image 2. So you can generate very detailed images directly inside the workflow. This model is pretty powerful. Here is the result after the patch. The textures are quite nice in this vintage style and the people now have legs. But our rifle is still super crooked and made out of the simplest geometric shapes. Let's ask it to make absolutely all graphics based on images rather than vector geometry. So the game looks much more polished. Also, the player's rifle should point toward the center of the image like in real Counter-Strike, not sideways. To make it clear, I'll attach a screenshot from the real game. In Codex you can upload images and the model can look at them through its vision capabilities and understand what's shown. You can add images by dragging and dropping files or screenshots. Convenient. After an hour of Codex working, I get this much more upgraded version of the game. I like it. Everything already looks pretty solid. In the dialog you can see how the agent generated a bunch of images. By the way, it's important to understand that the current OpenAI image model, GPT Image 2, cannot generate images with a transparent background. So for textures like this, where we need transparency, you have to use workarounds like generating a chroma key or calling some third-party models to remove the background. This process isn't super critical here. Codex cut things out using chroma key, which is fine. However, the characters in the game are still too tall and for some reason we have two crosshairs at once. Let's fix it. Instead of watching the development, we can enable notifications, so we can see that the agent has completed the task. To do that, let's open Codex, Settings, General, Notifications, Turn Completion Notifications, Always. I also enable notifications for the app itself in macOS notification settings. Nice. Now we'll know when Codex finishes. Let's send it to the game and go drink some tea. When the work finished, I got a notification. The fix took 15 minutes. The result, the issues were fixed. Overall, good enough. By the way, why does development take so long? The main reason is that we are using GPT 5.5 at the extra high reasoning level. This is the most powerful setup OpenAI currently has, but it's also the slowest. I usually stay on it because I don't want to lose quality on task execution, but for certain tasks where speed matters, you can safely test different reasoning levels. Low is the fastest. You can also try other models. Among OpenAI's ultra-fast models, GPT 5.3 Codex Spark is pretty interesting. It isn't as smart, but the speed is genuinely impressive. You can also get an extra speed boost of about 50% by enabling fast mode, but keep in mind that this mode consumes 100% more tokens. You can use it with the same GPT 5.5 extra high setup, so you don't wait forever for the result. So with Counter-Strike everything is clear. It can be tuned and improved further, but this example shows the main weakness of current LLMs. Problems with vision accuracy and the difficulty of testing visual output. Neural networks are pretty lazy about controlling visual quality. They don't really understand what looks good, what feels clear, or whether there are interface glitches. During development of the Counter-Strike clone, the Codex agent called the browser use tool to open the running game server in the built-in browser, clicked around the interface and checked screenshots of the game. You can also use this tool to test front-end behavior on your own website. Here, for example, I asked Codex to check a button on my test stand. If you want to use your own logged-in accounts, you can install a convenient Chrome plugin called Codex. It's easy to find in the Chrome Web Store. It lets Codex control the browser if you mention the Chrome plugin in the dialog. For example, this way you can collect useful data from other websites. Here I asked the agent to check tool popularity in Google Trends, but as soon as I wanted to parse more information about other tools, I immediately got too many requests from Google, so parsing large volumes with it probably won't work. Codex can also call the built-in computer use tool to manipulate your computer outside the Codex app. This is useful for specific cases where you need to test the visuals of native macOS apps or automate something inside them. For example, here I asked Codex to complete the game Everlasting Summer. Codex only managed to work with the native App Store version. For some reason, it refused to recognize Steam games at all. Controls simply didn't work there. At the very beginning, the agent got badly stuck on existing saves and really wanted to load them. but those saves were missing in the App Store version because they were tied to the Steam version. I had to hint that I wanted a playthrough from the very beginning without saves. Then Codex started widely clicking through dialogues. It stopped at choices, picked something and then kept clicking. It was going pretty well, but after 20 minutes of that speedrun, Codex first got stuck on the location selection map, and then on a card game where it had to choose moves properly and understand what was happening. After a couple of moves, the model context overflowed, the chat got compacted, and all the game control abilities disappeared somewhere. Codex started trying to control the MacBook through some tricky Swift code. At that point I stopped it. It looked like we would never reach the end with this approach. So computer use seems decent for simple automations where you need to click a few buttons, but it's too unreliable for long visual flows. Now let's make something cool and useful. Let's create a kind of personal Jarvis that sits in the corner of the Mac screen and does whatever I want under the hood. To do that, we first need to think through how it should work. I want my assistant to appear as an overlay widget on top of all windows in the system as a small button. Clicking it should start a conversation with the AI assistant. The assistant should run on Gemini Flash 3.1 Live. I like the voice and speed of that model. I also want the assistant to be able to call Codex CLI with any prompt I ask for during our conversation. I want it to be able to just chat, so it should only call Codex if I ask to. It should also have access to a server-side Google search tool, so it can discuss current information. Codex should open in a new iTerm tab in this folder in interactive mode, so I can continue sending prompts to Codex manually in that terminal. After launching Codex asynchronously, the assistant should keep talking rather than waiting for Codex to finish. If the user clicks the widget to hang up or says they want to end the conversation, the assistant should end the call. Before development, let's clean up the Codex folder. We'll move the Counter-Strike project we built earlier to this folder. All new assistant code will go here. And first, let's ask Codex to write an AGENTS.md file with rules describing what goes where in our service. I'll explain that the services folder will contain various projects and the system folder will contain scripts and utilities for our workflow. This is the content we got. The agents file in Codex projects is basically the main rule book that Codex follows in every session. By default, it always tries to find this file. We'll add the description of how to work in our base folder. Let's also refactor the rules system right away, so the rules live in a rules folder as multiple separate markdown files, and AGENTS.md simply says that the rules are located there. This instruction setup will be easier to expand and change in the future. Okay, it created two similar rules right away. I'll ask it to merge them into one. By the way, in Codex it's convenient to reference specific files using the @ symbol. When you type it, you get autocomplete for files and folders in the project. This is much easier than typing file names manually. Okay, now we have one rule. Good. Now I'll ask it to initialize Git in our project. Git is a version control system. It helps us avoid losing working code if something goes wrong, because Git saves the full history of changes across all files. Vibe coding without Git is extremely dangerous. If you don't know what it is, dig into it. It's a must-have topic. I also want Git initialized in this folder in a specific way. Each object inside services should have its own separate Git repository. The services themselves should be ignored in the main Git repository of our folder. This structure lets us work properly on many independent projects, deploy them separately to different servers and avoid mixing all their code into one repository. At the same time, the code of our management system will be stored separately, and we'll see its changes without mixing them with the projects we are working on. Okay, two Git repositories are now visible in VS Code on the side, one for CS and one for everything else. Let's commit the initial state everywhere. Great. Now we can almost start developing our assistant. But for more accurate work with code, I'll connect to MCP context 7 so the coding agent can read up-to-date documentation. Let's recall briefly. MCPs are extra tools for your coding agents. They work in Claude Code, Cursor, Codex and many other places. By default, your agent can work with files and the terminal. With MCP it can access databases, manage task boards, control browser and so on. Context 7 specifically gives our agent two new commands. The first one searches for libraries by keywords. In response, the agent gets a list of the most relevant libraries. With the second command, the agent can read detailed documentation for the library it needs. Since we want to work with macOS and native Apple related stuff, Codex 7 will be extremely useful. You can install it by going to the Codex 7 site, opening install, copying the command, pasting it into your computer's terminal and following the instructions. Log into Codex 7 and you are done. If we go to Codex, Settings, MCP servers, we can see that Codex 7 has appeared there. Also, when installing it, keep in mind that the command starts with npx, so you need to have that available before installing the MCP server. If you don't have it on your computer yet, you can simply ask Codex to install it. In general, Codex can install almost anything on your computer. This is often 100 times easier than running commands yourself and trying to understand what some errors even mean. MCP servers can be installed in many ways. You can click everything manually in settings or ask Codex to install them. That works fine too. So how is MCP different from skills and plugins? Earlier we already used the Imagen skill which generated images, and we used the computer use plugin. Basically skills are just instructions plus some extra resources that explain to the agent what to do and how to do it. Since image generation is a built-in Codex capability, Imagen is essentially just a prompt explain how to use it, plus a couple of code files for programmatic image processing. You can also add your own skills to Codex when you want to reuse certain instructions many times across different projects. If your prompts are relevant only to one project, it's probably better to put them into AGENTS.md. You can create your own skill by making a folder in here with a skill.md file in this format. At the top you specify the name and description of when it should be used. Below that you write the detailed instruction you want to put into the skill. Codex will see the list of existing skills. By default it only knows their name, description and folder path. Everything else is read only if the agent actually wants to use that specific skill. By the way, to avoid worrying about all these details and make creating skills easier, Codex has a skill called Skill Creator. It knows all these rules and helps create everything from easily in one prompt. Plugins are basically packages of MCPs and skills. For example, in Codex you can install a Gmail plugin that lets you work with Google Mail. It contains both skill instructions on how to work with Gmail and exact MCP tools for reading and sending emails. I recently found an interesting use case for this MCP, searching for information in email history. For a visa application I needed to list all countries I had visited in the last 5 years, with exact entry and exit dates. Reconstructing this from passport stamps is almost impossible, because some countries lets you pass through electronic gates without leaving any trace in your passport. So I tried searching for tickets in my mailbox through this Gmail plugin in Codex, and it worked insanely well. Codex found all the tickets and hotel bookings and successfully reconstructed my travel history. The plugin is awesome. Plugins can also be created from scratch locally. The process is similar to creating skills. Codex can also explain and show everything if needed. I prepared this prompt to create our assistant. Before running it, let's generate a key for Gemini. To get it, go to aistudio.google.com, login, open get API key, create a key, create a project, give the key a name and copy it. Then you need to set up a Google billing account so charges can be paid. I'll put the key into a.env file in the assistant folder. Files like this are commonly used for secrets and other program parameters that are convenient to update later without changing the code. Let's begin coding. After some time we can see Codex 7 tools being launched. The agent searches for libraries for working with Gemini, then it requests specific documentation content. After 10 minutes we have a working prototype. The widget can be moved around the screen with the mouse yet, and for some reason it doesn't stay on top everywhere, but it works. I'll ask it to write a 3JS game. I don't know, maybe create random game.
I can help with ideas for a game. Are you thinking of something digital, like a simple puzzle?
Codex really does launch in the terminal with the right task. It develops games in the services subfolder and they even work. Great. So what's this other Codex? This is Codex CLI, the console version of Codex. It can do roughly the same things as the agent in the app, but it can be conveniently embedded into other programs. In our case, we embedded the Codex CLI launch into the assistant widget. To install Codex CLI, run this or this. This codex has the exact same settings and parameters. They are just controlled a bit differently. You can set them when launching the codex command or change them inside the running program using /commands. For some reason, Codex inside our automation currently starts with default permissions and asks for command approvals. That's inconvenient. At runtime you can change the permission level with /permissions, but we need Codex to always launch with auto review. This can be set by launching the command with this addition. And if you launch the command with quotes like this, the text will be passed at the initial prompt. This is exactly what our assistant does. Another cool thing that all sessions and requests across all the versions of Codex are synchronized. For example, our some prompt request appeared in the Codex app. Okay, let's fix all the necessary parts in our widget. We'll switch to the dialog where we build the assistant. By the way, if we wanted to continue working through the Codex CLI interface, we could do it with the resume command. We'd launch Codex with it inside the project folder and choose the needed chat from history. In the console we can see the same requests we made in the app. It's important to understand that the dialogues shown by the resume command correspond to the folder you were in launching it from the terminal. If we run resume from another path, we will see a completely different chat history. The principle is the same as in the app. Chats are grouped by project, projects and folders are the same thing there. One more thing. Before we continue, it's better to commit the current state of our system to Git, because the assistant already works in some form. It would be annoying to lose the more or less working version, especially if future improvements break something. If we open the project folder in VS Code, we can see changes in the Git tab. I'll enter a commit message and commit this manually for reliability. We can see that our commit appeared in the version history. I strongly recommend learning Git if you are not fully confident in how it works. It's crucial when we are talking about the reliability of code changes, releases to production servers, and so on. Without it, you can't launch any project for real users. But if you're confident, of course you can ask the assistant to commit and work with Git automatically. That can often be faster, just always keep Git in mind. Finally, we'll run the fix prompt. After some time, the widget can be dragged normally, but it still isn't visible over full screen windows. Let's fix that. After the changes, widget visibility became correct, dragging works. Let's check the conversation on Codex launch. Yep, Codex CLI crashes when launched from the assistant. I'll ask it to fix that. After this fix, everything works great, nice, I'll commit it. Now I have 3 project states: before the assistant existed, when it basically worked but had issues, and where it works without bugs. In the future, I'll be able to return to any of these states, change things, and branch the project into as many alternative versions as I want. That's the point of Git. By the way, I'm also writing this video script in Obsidian, where those files are also committed to Git for reliability. By the way, using Git in Codex also lets you do interesting things. For example, you can branch the project into several independent versions and run changes in each one. This feature is called Worktrees. Before using it, let's ask Codex to prepare a script for initializing env files and other settings needed for Codex Worktrees. Without that, Codex won't be able to run parallel versions of the project later. Let's commit the script to Git. Now we'll run a prompt by creating a new chat. I'll keep the same project, but instead of work locally, I'll choose new worktree. For example, let's try making 3 design versions for our widget. I'll write a simple prompt, create a cool design for the assistant. I'll run it 3 times in 3 different worktrees. All of them work completely separately and don't interfere with each other, even if they edit the same files. How does it work? Codex copies your code from the Git repository into its own special folder, creating a new subfolder for each worktree. Then agents work there in parallel in neighboring directories without conflicts. When copying, Codex uses Git, so all the junk ignored in our repository through gitignore file doesn't get into those folder. Secrets from env file don't get copied either. That's exactly why I made Codex create the initialization script in advance, so all versions can work with our configs from the original env file. After development finishes, we can ask Codex to run all versions, and here we go. 3 little circles are running in parallel on my screen. Awesome. They can still talk to each other. Funny. But as you can see, in terms of design, all of them use roughly the same palette. Blue, green, black, white and a bit of yellow. This is the default style of modern GPT models. They basically can produce something unique by architecture if you feed them a generic prompt, because LLMs always return the most likely result, which means an average result. To work around this, you can use tricky prompt as input, but I don't want to invent something new every time I simply want some cool design for another app. Let's build a universal solution for that. I have an idea to make a random design prompt generator. Something like this. Take several categories, colors, era, mood and so on. Create several ready-made options for each parameter. Then for a new project, randomly pick one value from each option and get a completely random mix. Feed that mix into the model as the design style prompt. That way the result should always be unique. Maybe sometimes weird, of course, but still interesting. Let's test the idea. In a new tab I'll run this prompt. I added different prepared parameters and values there. We should implement it as some kind of MCPs so it can be connected to any agent chat without problems. I'll ask it to put the code into services random design MCP because it's a separate project, not part of our work system. Since development may take some time, I will go to a shop. But if we don't do anything, the computer will go to sleep and stop development. To prevent that, we can enable the setting prevent sleep while running in Codex, settings, general. Now the computer won't sleep. I'll also connect my phone for remote control of the Codex agent. To do that, I click Codex Mobile on the computer and Codex on the phone inside the ChatGPT app. After enabling two-factor authentication and connecting, I can control the local Codex instance remotely from my phone. Here we can see all projects and chats. Our MCP is ready. Let's test it in a separate chat. Yep. We can see the MCP being called. This is the prompt we got. Looks like it works. Okay, I'm going back home. Now let's send the same prompt to our Worktrees. Redesign everything based on the prompt from the random design tool and restart the widget. These are the updated designs we got. Nice, but I'd like something a bit more minimal and a bit more technological. Let's write a prompt asking for minimalism and also try a gambling style approach when the agent rolls design prompts until it gets something technological. In the MCP call history, we can see the agent rolling different prompts. Pretty cool. As a result, I get these design options. They are already calmer. The neon design is pretty basic. The center one is fine, but the right one has interesting effects. Something in the style of the TikTok logo. I like it the most. Let's apply it to our main project and save it in Git. To do that, I choose the needed chat, click Info, Worktree, hand off to branch and enter the branch name. I don't want to create a new branch, so I'll enter main. After the process finishes, VS Code shows that we are still on the same main branch and just have new design changes. I'll commit them manually, done. Now let's upgrade our assistant even more. Right now our program opens Codex CLI when we ask it to, but it doesn't track execution progress in any other way. I'd like the assistant to manage all these sessions, see what's done, what's running, add follow-up prompts and so on. Let's try to implement that. I prepared this prompt, all of this work based on Codex Exec. What is Codex Exec? It is a command that lets you launch the Codex agent without any interactive stuff. You just give it a task and it works. This is the most convenient way to embed the agent into pipelines, bots and similar systems. Codex Exec works the same way inside OpenClaw and Hermes agents. Internally everything functions as before, but externally the calling program can easily understand that the process has finished and then give the next task or move to the next step. That's why we'll use it in our system. Now the assistant will control Codex sessions for us. Starting development. After some time the assistant is ready. Let's check it. Basically everything works well, but we need to add tools for continuing work in sessions that were interrupted. We also need tools for adding a new prompt to our running session on the fly without stopping it, so it picks up the new data and continues working with it. So right now our program only has something similar to adding a prompt after the task. In Codex App, for example, this is done simply with enter. In Codex CLI with tab. But we don't have an equivalent of stir sending like in Codex App when you click here. or the enter send in Codex CLI. This kind of send usually lets Codex read an additional prompt after the current tool call finishes. Codex kind of picks up the new data between steps. We need to implement the same thing. Run a fix request, OK. Codex implemented the new functionality not through Codex CLI, but through Codex App Server calls. In other words, it built a system that sends requests to the real Codex application server. This approach allows us to cover 100% of the Codex app features. Our sessions appear in the desktop app, which is super convenient. We'll be able to continue working on tasks there if we want. Everything works great. Codex successfully intercepted my command to change the snake's color while the task was still running. The chats appeared in the Codex app. Now we just need to fix a few small issues. First, I want to be able to monitor task status in the widget without talking to the assistant. And also I need a way to end the conversation without closing the expanded widget view. Then, if needed, I can call the assistant again later to continue the conversation. And there is no button to reset the conversation and clear the history. Also, in general, I think it should be possible to talk to the assistant without expanding the widget to full size. There should be a click to start a call, and another click should be able to end it. The micro version of the widget should have buttons like View Sessions, View the call transcript as text. The session button should show a small badge with how many tasks are currently running with some nice animation. And in expanded mode, the widget should support flexible resizing with the mouse. That's it. I'll send these changes to Codex. I'll also add that the design should be like Apple's liquid glass and the widget should be more transparent, because right now you can't see anything behind it. It's cool that in Codex you can move these planned prompts around and change their order. After all of the fixes, this is the design we got. Now let's polish a couple more things. I want a notification to appear when the task finishes. Sometimes you need to think through a task with Codex instead of immediately changing code. To do that, you can enable planning mode. It prevents the agent from editing files and forces it to prepare a clear implementation plan. It's a good thing to use when you don't know exactly what needs to be done or how. To switch into planning mode, type /plan, then send your prompt as usual. In this mode, Codex also asks clarifying questions about the task. Okay, I'd actually like signals for all task states, not just completion. I'll make the counter the way it recommends. As a result, we get a detailed plan of exactly how the agent intends to implement the feature. If everything looks good, we click implement. If not, we can add corrections and it will revise the plan accordingly. Now let's also add a task board to our assistant. It should store tasks in a new tab by project, and it should be possible to send them to Codex in one click. Visually, this will be convenient and clear for long-running projects. I prepared this prompt. Since it adds a lot of features, I will use a thing called goals. This is still an experimental feature in Codex. To enable it, you need to type this in the terminal. Codex features enable goals. Now, after restarting the app, we can see that Codex recognizes the /goal command. Everything we type in the prompt now becomes the goal of the session. At the chat level, this message appears almost like it's pinned. It won't get lost in very long sessions. Codex will try to achieve our goal and won't finish working until it thinks everything is done. For now, though, there are no extra subagents to check the result, so the agent still has bias. It can finish development too early without checking everything 100%. If you want true evaluation of a task completion, we can implement that through special subagents. In Codex, you can ask for this in the prompt. But first, let's check what happened with tasks. Everything works. The only problem is that the task action symbols are drawn as some crooked SVGs. We need proper templates. Let's fix that with real subagents. In prompts, you need to keep in mind that Codex doesn't use subagents by default unless you explicitly tell it to. So we'll specify that in the prompt. By the way, in Codex you can allow subagents to spawn other subagents, creating a complex hierarchy. During the session, the main agent spawned 2 workers for improving the UI and MCP, and then 2 testers for the same areas. After some time, everything passed. Let's look. Great, the icons are normal, project deletion works. Nice. Overall, we seem to have built a pretty interesting assistant. We can keep improving it and automating more and more things. And the last Codex feature worth mentioning today is automations. You can see the current settings in the automations section. There you can see what's already running, what prompt gets launched, and how often. You can create an automation either in chat by simply asking the agent to do something regularly, or manually through create manually, where you specify the prompt, project, model, and launch frequency. everything is simple. For example, here my agent is currently checking every 10 minutes whether a video is being uploaded to the Vibe Coders Club. If something goes wrong, the agent can calmly figure it out on the fly, instead of just logging an error like a normal soulless script would. So modern Codex is a worthy competitor to the Claude ecosystem. Most useful features like subagents, planning and automations are implemented there no worse, although each has its own nuances. Overall, with current GPT 5.4 and 5.5 models, Codex App can be used comfortably as a foundation for building any development projects, doing research or simply working with your computer more efficiently. Write in the comments about your own Codex setups and use cases. Subscribe to the channel, I'll keep experimenting with AI, building cool stuff and testing models and tools. That's it for now. See you!